Let's look at cot inverse of x. So we have, first thing is cot of x. Look at cot of x first. So we have the input values to range from minus infinity to plus infinity other than even multiples of pi by 2. So basically when you solve this, you will get it to be multiple of pi. Okay, even multiple of pi by 2 is nothing but multiple of pi, right? So if I skip the pi values, so or even multiples of pi by 2, we can see that the graph is varying from minus infinity to plus infinity. Actually, this is minus infinity. It's going towards plus infinity. Right? So that is your range and this is your domain. Domain excludes even multiple of pi by 2. So basically, cot of x can map any angle which is a multiple of pi, and it can map to all the real numbers. Right? So basically, now I can generalize that cot inverse of x will map the real numbers to angles excluding n pi. Next thing, let's look at the graph of cot inverse. So we have it to be similar to your tan, but yeah, please ignore the color. So it will vary in this manner. So it's coming from plus infinity, going towards minus infinity, right? So it's coming from plus and going towards minus infinity in each of the branches. So clearly here the domain remains to be real number, while the range can vary from quite a few things. So we are making use of the concept of branches over here. Only then it becomes a function, is it not? So remember, each of it covers all the possible output values, all the possible output values. So basically we are looking at minus 4 pi by 2, that is minus 2 pi to minus pi. So we have this to be minus 2 pi to minus pi to 0, and we can, it would be so, right? Let me do it from here. So this is minus 2 pi to minus pi. Again, this is the same line, minus pi to 0, right? And we have 0 till 2 pi, so on and so forth. 0 till, not 2 pi, sorry, pi, and so on and so forth. So which is your principal value? Sorry, not principal value, principal branch. Yes, it is 0 to pi. So it is 0 to pi. Yes, these are square brackets. We can't make it as, not square, small brackets. We can't make it as anything else. These are small brackets. So as a graph, we will be looking at something like this. So we have this to be your domain and range. So that's your domain. Graph will, okay, I have some space over here. And that's your range. So we have the asymptote. So it's actually along this line itself. So asymptotes are nothing but line that that represents, let me do it over here actually. Yeah, something like this. That represents an imaginary line which goes to infinity. So basically this line is what the graph is trying to touch, but it can never. So basically this is your 0 and that's your pi, and the graph moves from negative to positive. So it will be something like this. Let me confirm that. So this is 0. So you can see 0 to pi, the graph is moving in this manner. So our graph will look something like this. Okay, just a second. Almost better. Yeah, that's okay. So that is your cot inverse of x. It looks okay, right? Comparatively better. Yeah. Okay, that's the best I can do.